Hey everyone, Nick Genetakis here. In this video, let's take a look at a command line tool that I recently open sourced called Diff. And in this video, we're going to go over what Diff is, an example of using it, and we're also going to go over how it works under the hood because it's a 200-line Python script. So by the end of this video, you'll know how to develop your own standalone Python scripts that work for Python 2 and Python 3, and you'll be able to make your own command line tools. So let's just get started, because the easiest way to explain what this thing is by actually running it. So right now I'm inside of the Diff GitHub repo here, which is really just a Git repo, and I'm going to run the help menu for this tool. So it says here that it diffs every change between two different web framework versions, and it currently supports Phoenix, Rails, Django, and Laravel. Now, if you followed some of my other videos, you know that I am a Flask developer. I even have a course on Flask, so you might be wondering, like, why in the world doesn't this tool support Flask? Or even other tools like based on, or other frameworks based on Node, like Express or whatever the cool kids are using nowadays. So the reason why it doesn't work for Flask is because it doesn't really make sense for Flask. So in the case of Phoenix, Rails, Django, and Laravel, all of these tools have one thing, or all of these frameworks have one thing in common, and that's they all have their own little command line tools to generate a brand new project. So you can do something like Rails new blog to generate the scaffolding of a blog project. Whereas with something like Flask, there is no project generator, so there would be nothing to diff. So with that said, let's just go ahead and demonstrate what this thing does. So if I pass in a framework of Phoenix, and let's say that, and this is really like the use case of the program, right? So it's like, let's say that you're currently working on a Phoenix 1.44 application, and this could be a Rails app or a Django app, it doesn't really matter. And 6 months down the line, you're hacking away in your code base, everything is doing great, and you decide that you want to upgrade the version of your web framework. So usually when you would do that, like the first thing you would do, or at least the first thing I would do, is I would go and check out the upgrade guides or a change log to see what changed between the version I'm on now versus the current, versus the version that I want to upgrade to. And those upgrade guides are actually really good. Like they'll tell you, API changes, maybe this and that changed, but they don't really tell you exactly what files changed, because ideally, when you generate a new project using the latest version that you want to update to, chances are that generated project is going to have modifications to files that you've already modified. Now, that's a little bit tricky to explain, but let me show you here. So let's say that you're running Phoenix 1.44 and you want to update to Phoenix 1.48. So that's really all you would need to do with this command line tool. We're passing in the Phoenix framework, and then we're passing in, the version that we want to compare on the left and the version that we want to compare on the right. And then we can just run the tool. As we can see here, it's going to scroll away pretty fast, but there are other arguments that we could have passed to this tool, and we'll go over that a little bit later once we get into the nitty-gritty of how everything works. So as you can see here, about 10 or 15 seconds later, we actually got a diff of these two projects. So all of this stuff was boilerplate for generating like a Phoenix 1.44 application, and also over here it's generating a Phoenix 1.48 application. And by the way, all of this is running inside of Docker, and we'll take a look at that once we start looking at the source code. But once we have two of these projects generated inside of a Docker image, and that image gets built, then all I do is I run that image and I use the diff tool, and now we can see exactly what files changed between both of these versions. So we can see here like a different key got generated here. That doesn't really matter because that's random. Like these are randomly generated. But down here is a really good example with plug logger versus plug telemetry. So in Phoenix 1.44, it was still using this plug called logger, but now in Phoenix 1.48, that went away, and now we're using plug telemetry. So also here's some other random stuff, like things changed in the mix file, super specific to Phoenix, but this really gives you a great heads up on what changed between these two versions, because now what you could do is you can go into your code base. Actually, this is a really good example here, like this errors on function. So this is some function that gets generated into a file. In this case, it's a test file called datacase. And now imagine if you are running your project, on Phoenix 1.44, and you just upgrade it to 1.48. Chances are you would want to go to your datacase, that file, and then replace that function to be the green over here. So now you'll have that updated function. Because really, let's be honest here, if you're going to upgrade web framework versions a couple months after you started your project, like you're not just going to generate a brand new project from scratch. So that's really, why you may want to use this tool. Personally, I use it quite a lot for some freelance work. Like if I'm updating someone's Rails app from version X to Y, then I would use a tool like this to see exactly what I need to change in the application. So let me clear this screen here and also go over a couple of other flags that we can do here. So, and I'm not going to spend a ton of time here because otherwise this video would get extremely long. All of this stuff is very well documented on or in the README file on the GitHub repo, so you can check all of that out. But we can see here, okay, so you pass in the framework name, which is technically optional because if you admit putting this in, it's just going to default to Phoenix. Then what you could do is you can actually put in a project name. And we can see that, like, for example, if we wanted to name the project hello, you would just put in the project name. And that starts to make sense when we take a look at the other option here, which is save, which will actually take those generated projects that we just ran. And instead of the Docker image being deleted afterwards, it's actually going to copy those projects out to your file system. So, if let's say, I know Laravel tends to have a lot of changes, but Rails too, depending on what you're updating. So if you find that the diff output is a little bit too crazy to read in the terminal, and you'd rather use your code editor's diffing tool instead, what you could do is you can just pop in the -- save flag, and now we'll be able to access that in our code editor. Also, the reason why the project flag is nice to be able to set hello or whatever project name that you want is typically like my whole entire development environment is set up in Docker. So if I'm working on a Phoenix application or a Rails application, I actually don't have Elixir and Ruby installed directly in my dev box under WSL. Those programs are all running inside of Docker. So when it does come out to wanting to create a new application, like let's say I just want to start a brand new side project or something like that, typically I would want to use the Rails new generator to generate a new project, or a Phoenix new if I'm using Phoenix instead. But, that would require having Elixir and Phoenix installed, within my WSL instance. But I don't want that. So what I would typically do is, I would go ahead and run like an Elixir 1.9 Docker image, and then I would manually install Phoenix, manually run the Phoenix new command, set up a volume mount, and then generate that new project somewhere within, my file system locally. And then from there, I can just develop it like any other Dockerized application. But, that's a ton of different steps that you'll have to do manually. So if you just pop in -- project hello, meaning like where hello is the project that you actually want, and you run this command, then what's going to happen is it is going to poop out a Phoenix folder in the current directory of where you ran this script. And inside of that directory is going to have, well, let's take a look here. If I do an ls here, we can see that we have this Phoenix folder here. And that folder was not there before. That was generated due to the -- save flag. And if we go in there, we can see both of our versions that we want. For example, if I wanted to actually diff these projects in Vim using a Vim plugin, I could just run vdiff and pass both of those in. And now I can see a better look at what exactly changed between both of these versions. Now, this actually looks like absolutely horrendous because my font size is 1,000,000,000. So that's not a really good example. So let me just quit out of Vim here. And really what I wanted to show here was like if I go into this version over here and take a look, we can see that, let me just clear that so we can see it. If I go into this hello folder here, like that is a brand new hello project that was generated with Phoenix. And if we take a look here at one of the files here, like hatmix hello, whatever, we can see that, the name of the project is hello. It was really generated with that project name. So passing in the project name is quite helpful when you actually want to generate a new project. Otherwise, if you don't put in a project name, then it is going to generate it with a timestamp. So usually the project name, if you're just diffing version A versus B, isn't very important. So let me just get rid of that Phoenix directory there. And if I do a couple up arrows here, well, quite a lot now since I've ran a whole bunch of commands, then we'll just run this help menu one last time, and we'll take a look at a couple other flags here. Now let's take a look here at the bottom where we have two other flags called keep image and keep dockerfile. I'm not going to really bother running these, but let's say if you were to supply keep image, which is a Boolean, you can just put this flag on its own. It is going to keep the Docker image around instead of deleting it afterwards. And then likewise with keep dockerfile, this program, it does generate, actually that would be a good one to show. So let me clear this here, then do a little bit of control R action here. And you can see all of the crazy commands that I've ran in the past. Not that crazy, but if I go over here and instead of saving this, I'll just do keep dockerfile. And if I run this command now, what it's going to do is instead of generating a Dockerfile, building the image, running the container, and then deleting everything afterwards, it's still going to do all of that, but it's going to leave the Dockerfile in the current working directory, which you can see here is labeled with a timestamp. As for the specifics of why is there an A in front of there? Well, some web frameworks, they require your project name to start with a letter instead of a number. And if you don't supply your own project name, then it uses the timestamp, but a timestamp starts with a number. So I just put an A there. So if we actually take a look here at this Dockerfile actually gets programmatically generated by the command line script. So since we're using Phoenix, it's pulling in like Elixir, and then it's really running all of these commands to build our image. And then the default command that gets run when we run the container is just the standard diff tool with a couple of flags here. That's it. Now, with that said, let's take a look at the source code to see how this is implemented. Also, let me just show here, there's really nothing inside of this directory besides the vir.diff script. Everything else is pretty much boilerplate for publishing it on GitHub. So like there's a Travis file, a changelog file, a license and a README and things like that. By the way, inside of this README file here, it really does go into quite a lot of detail on like what you would expect when you run it, maybe the use case and why you would want to use this tool, what I was doing before this tool existed, which was actually a super tedious workflow here, which I did used to do. And then, it just tells you how to install it. Since there's no dependencies, then all you really have to do is just run this one command here. You can copy paste that from the GitHub README file, just basically put it somewhere on your system path, and then you're done. And then there's a whole bunch of examples on how you can use it. Also, one thing I didn't go over here was this debug1. So if you put that before the command, then it just outputs some debug information. So you'll be able to see like what Dockerfile got generated without having to use save and all of the Docker commands that were run. Now, with that said, let's actually take a look here at the file itself. So if I go down to the bottom of the file here, you can see that it is 227 lines long, which is really not that bad, considering if we were to break up this file. So like the first third of the file really is just a whole bunch of, I don't want to say boilerplate, but it's like configuration for each supported framework. And we'll go into this stuff in more detail, don't worry. And then like over here, like this generating that Docker file that we just took a look at. So, this is quite a lot of lines of code from line 70 all the way down to here, 114, it's like 40 something lines of code where like a majority of that is just generating the Docker file. And then we have a couple of functions here that are super specific to this script where we just call out to some Docker commands on the system. And we are going to go a little bit more into detail on these. I'm just giving a very high level drive-by right now. And then basically the bottom half, like, the last whatever 50 or so lines are basically just using Python's arg parse library, which is driving our command line functionality. And that's really where I want to focus most of the time in this video, because if you want to develop your own command line script, then using arg parse is pretty nice. And there's a number of examples that we can look at here. Now, first up, if you did take my Flask course, you know that we are not using arg parse in the command line section of the code base. So in that course, we do develop our own like CLI component where we can do things like seed the database and then do some migrations and some other fun stuff. But in that case, we are using the click library, and click is a really good command line utility or it's a good, I guess you can call it a framework for building command line applications with Python. However, click is not part of Python's standard library. And I really wanted to create just a very simple standalone, like, I didn't say 200-line script before I wrote it, but, a very simple one-file Python script to handle everything. Like, I didn't want to have to worry about, pip installing click or requirements files and all this other stuff. So that's really the main reason why I'm using argparse instead of click. And also, this tool is not very big. There's not, a ton of different commands that you would run, with a million different flags and other stuff like that, where click really handles that use case very well. But you can still build some really robust things with argparse. And now let's take a look at what's going on here. So when we went and when we took a look there at the help menu before, so that help menu is really being generated by what we see over here. So really there's this one class, like the formatter class, called raw description help formatter. And this is all in documentation. Like if you just Googled for like Python argparse and then put in that, then you'll get an explanation of what it does. But the TLDR is basically, we're telling argparse that we don't want it to format our help menu. Like whatever we supply here is exactly what we want the help to look like in terms of formatting. So in this case, we have like diff every change between two web framework versions, new line, and then like supported web frameworks, variable, like the formatting here, like even here, there's like 2 extra spaces there just to indent that a little bit. And then here we're just using, string formatting, what .format. And then we just take that, if I jump back to the top of this file here, we have this list of frameworks here at the top of the file on line 10, where it's all the supported frameworks. And then if I just go back to here, it's that's what we're putting in there. So then, and we're just joining it on comma space. So in the end, if we actually run verdiff --help, then we can just see a comma separated list of supported frameworks. And we can see here that the indentation is set up exactly how we have it over here in our file. So that's kind of how you can write a very quick help menu. And for the other things too, like, how did all of this get set up? And like, how did all of that get set up? Well, that's just what argparse gives you based on the arguments and things like that you have defined. So in our case, or in the case of this CLI application, it expects that we pass in at the very least 2 versions, right? Version A and version B, left side and the right side. So we're just using this argparse add argument versions, and there's no default, meaning it's going to be required. And the number of arguments that we expect are 2. So we could have put like 4 here if we wanted to have 4 versions. Like that doesn't really make sense in the context of this CLI tool. But if you have some other tool that requires 4, then you can put 4. And there's also other nice things that you can do. I always forget them off the top of my head. It's things that I would Google when I need them. But I think you can put in something like the plus symbol or an asterisk, and you can basically say like 0 or more or 1 or more. So if you have a whole bunch of arguments that you're not really sure of if you need like 3 or 30 of them, then you can use that. Basically just Google for like Python argparse and args, and you'll get some great examples. But some other stuff too, it's like we have this metavar thing, and we'll go over that in a second. But we also have type string, which is really nice because now, we can expect that when we deal with getting the value of these versions, they're going to be casted to strings. So now let's take a look here at the metavar and help. So the help is, both versions that you want to compare. So if we jump back over to the help output here, we can see here positional arguments versions, both versions that you want to compare. So argparse is really just taking all of the arguments that you've defined, and it's building this out for you based on, like, so in this case, like versions is the metavar, or what is it called? Yeah, metavar versions. So in this case, let's take a look at the next one, which is we're adding a command line argument framework. And the default in this case is going to be Phoenix. So we can actually run the command without supplying -- framework. And if there's nothing defined by the user, it's going to fall back to Phoenix. And in this case, we're actually using a custom type called some supported framework. And that isn't something that comes with argparse. This is just regular, good old Python. So if we go and take a look here, actually, let's take a look at that in a second. We'll just finish up looking at this one with the metavar name. And like, here's another help explanation for framework. So if we go back to the -- help here, we can see how we have framework name, where name is the name of the framework that you want to pass in. And then, there's the help line. But now let's take a look here at this custom type, because this is how you can define your own types. So if I do a search here for supported framework, it is just the function, and it just strips the string, and then it does like, if string in list, in this case, like the list of frameworks, then we return the string. So the way that works is like, let's say that you were to put in the string Rails. We would strip it, and then we would be like, if Rails in that list of frameworks, that was, a couple elements of the supported frameworks, then we return Rails. Otherwise, if that is not true, then we just say like, that's not a supported framework, and then we raise an arg parse argument type error with the message that we have here. So we can actually see that in use here. If I do framework foobar and I run that, now it says here, verdiff error argument framework, not a supported framework foobar. So that is pretty nice. That's one way to do validation when it comes to argparse. So we just basically just created a custom type. We didn't want to use string because string technically, like foobar, would be a valid string. So that's why we're using a custom type. Also, man, it is super hot here. I can't have the AC on doing a video because otherwise it's impossible to hear anything. So I'm suffering. It's like 90 degrees here. Okay, so the next one, we have another argument, -- project. You can pass in the name. And in this case, the default is this thing called project name suffix, but we'll get to that in a second. Type string, help menu, metavar, very similar to framework. -- save. Well, let's save that one for later. And actually, let me go up to here where we're doing the project name suffix. And remember when we were talking about timestamps and project names having to start with a letter? So I did comment here because this is a strange thing. So some people say like, if you can't read your code without comments, then your code sucks. But once in a while, like you do need to write some comments here. Like, why on earth is there just a floating A there? Like, if you didn't know the context of why that's there, then yeah, it gets very confusing. So I wrote a comment there. So basically, this is the default value. If there's no project name, then it just uses that and it generates that based on what we have defined. In this case, the project could be any string name. I'm not going crazy with validations. Like, I don't know if Rails new will accept a project name of like, -- exclamation point, like probably not. But, in that case, that's like a Rails new problem, not so much like a diff tool problem. So I'm not too worried about going completely berserk with validations there. And now the other ones are all basically, so save, keep image, and keep dockerfile. These are all pretty much the same. So you can see here that it has some flag like save or keep image, and default is false for all three of them because we don't want that to happen by default. These are all Booleans, so they can be true or false. And here we're using args to say, I hate to give bad information on video. I don't know exactly if this means 0 or 1 arguments. I think it might, but again, these are things like, I've got a decent amount of programming experience, but when I don't know things like this off the top of my head, it's like a 10-second Google search away. So, and again, like the metavar is a bool. So if we take a look here, we can see that we can just put in true or false, or actually just true, I think in this case. I don't know exactly what would happen if you put in false. It might think that we're passing in a value to it and then evaluate to true. But in either case, if you do save by itself, that'll actually work. Or if you do save equals true, that'll also work because we have this const equals true thing here. And that really protects us against the case where we just put in -- save without putting in like true as the value. Let me show you an example of what I mean here. So if we do like Phoenix here and we go to -- save, this is going, if we actually do nothing else and just run this command, that is going to make this argument save be the value of whatever we define as the const. So if we wanted that to be false or whatever, we'd have to put false here, which is different than the default itself. So when we have the const equals true set, it just means that we can type save, or we can type in save equals true, or we can type in true, and all of those are going to evaluate to true. But although the const specifically is to make this evaluate to true without having to explicitly type true. Wow, that's a tongue twister. And then for adding arguments here for keep image and keep dockerfile, literally the same exact thing. Only thing that changes is the help menu. So now it's like we got a list of all of our arguments and things that we want. And then we just do parser.parseArgs. This is all again in Python's documentation for arg parse. And now we can start doing things with all of these arguments. So in this case, I just extract out versions here, because remember, args.versions, there's 2 of them. So when we get this back from Python, it's going to come back as a list. And I just want to be able to grab the first element of the list and the second element of the list. And the first element is going to be, in this case, I don't have it typed out, 1.40 versus 1.47. So like this one would be the 1.40, that one's the 1.47. And then when we want to reference something like the project name, we just do args.project. And the way this naming convention works is, like, if you have a flag named -- project, then your args is going to be that project. And when it comes to something like keep -image with a dash in the middle, then that dash gets converted to an underscore. And we can just reference it with args, keep _image. Also, if you wanted to do some debugging here, you can do something like print args. And let me just do a little bit of a tracer bullet here so it's easier to see the output, because this program has a ton of output. Let me also get rid of debug mode here. And then let's just do 1.44 versus 1.48 because there's not that many changes here. And we can also see, like, I'm not going to even supply the framework now because it should just default to Phoenix. And actually, I'm just going to kill that. But there's our tracer bullet. I like to call them tracer bullets. But we can see here, what we did here on the left-hand side was we printed the arguments here, right? So now if we take a look at that, we can see that, okay, the framework is Phoenix, keep blah, 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 this is blah, 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 blah. There's our list of versions here. So printing out args just gives you a great way to see all of your arguments. So very helpful for debugging. And then over here is more just, really specific stuff to this application where it's like we generate a Docker file. But to generate this Docker file, it requires passing in the framework, the versions that we want, and the project name. And then we have a couple of Docker commands here that I wrote for like building the Docker image, running the container, and then removing everything afterwards. So if I go over here to like generate Docker file, it takes in the framework name, version A and B, the left side, right side, the project name. And then like, what's the framework? Well, the framework really is, actually this framework is a dictionary, and we're taking the dictionary, we're taking a value from this framework dictionary by the framework name. So we're just looking up the key of the dictionary. And once we get that, then what we can do is we can use, Python string formatter, and we just extract out a whole bunch of information from that dictionary. So like the base name, which would be the base Docker image name. Then there's like system dependencies that we want to run and all sorts of stuff like that. And then we just basically template out the Docker file. So like from base name. So what is base name, right? Base name is coming from down here because we can use named variables here instead of using the numbers. I actually started off using numbers, but when you use numbers and you have like 9 or 10 different things that you're passing to format, you just end up with like a spew of numbers here, like 0, 1, 3, 5, 7, and it's very, very, very hard to understand what's going where. Also, if you're wondering why I'm not using F strings, so with Python, you can put an F before the string, and then you can just reference things by variable names, but I wanted to keep this script compatible with Python 2 and 3, and F strings are a Python 3 feature. They're not in Python 2. However, doing that format with named keyword things here allows you to reference them in a similar fashion to F strings, but it's a little bit less nice because we have to use format. But if we take a look here at the top, there's that framework dictionary. And, if we just did a diff on Phoenix with 2 versions, and Phoenix is the framework name, then it's going to find the item from the dictionary here, and this is the value. So here we can see like the base image is, Elixir 1.81. Although Elixir 1.9 just shipped, I'm going to wait until Phoenix 1.5 comes out before I change this repo to use 1.9. Although this doesn't really matter because we're just generating a project inside this. This is not meant to be like the actual runtime environment for the project that you generated. Like you would have your own Docker file that would pull in whatever Elixir version that you want to support in your Phoenix application. So, and we can see here like Ruby is using this, and Django is using that, and Laravel is using that. And now we have things like pre-run instructions, like these are things that need to happen before we start like installing things like Phoenix, or in this case Hex, or creating the new application. These pre-run instructions, there's really only one for Laravel, where I just want to make sure a composer is available. And I don't want to get too deep in the woods here when it comes to the specifics of all of this stuff. Just know that like something like Rails, it requires having build essential installed, and libpq dev if you want to have Postgres support. So like when we generate the new Rails project, most developers using Rails are using Postgres. So when I do the diff on, when I generate the Rails new project, like I am passing in Postgres here. And so we need libpq dev in order to get the Postgres gem to install when we generate Rails. So some of these things, like for example, Phoenix, and the reason why I used Phoenix as a working example for this video is because Phoenix doesn't require any system dependencies to be on the system to generate a new Phoenix application, meaning it only takes a few seconds to generate instead of a few minutes. For example, like the Laravel one is completely bonkers. So like, I don't want to make fun of Laravel or whatever. Super popular, really great framework if you like PHP. It's not my cup of tea. I have some reasoning for including Laravel here, mainly because I'm working on a new course to do application deployment, and I wanted to have a Laravel example app to deploy, and I wanted to keep track of being able to update like the example Laravel application. But it takes like 7 or 8 minutes to generate these projects with Laravel, whereas Phoenix, couple seconds, Rails, maybe 30 seconds, Django, also pretty fast. I think even faster than Phoenix, maybe. But the Phoenix one was more interesting because there was a number of things changed between both versions that we can take a look at. Whereas with the Django one, it was mostly just like little things like documentation URLs, like the version number changed. Also, if you're wondering like what's up with the bin true, so inside of the dockerfile template over here, we are doing, what are we doing? I'm trying to find the install system dependencies. Yeah, so installing system dependencies, if we take a look at that, it's something we're just using with a run instruction. In this case of Phoenix, where we're not doing anything, we just wanted to use bin true because that's pretty much like the easiest way of just having a successful command do nothing. Whereas like with Rails system dependencies, well, we want to do an apt-get update and then install these libraries. And I didn't want to do like an apt-get update for all of the supported frameworks, including installing all the dependencies, because it does add quite a bit of time to the diff tool for that to take place. But that's pretty much this entire script. I mean, if you have any questions about the source code, leave a comment, and I will definitely take a look and answer your questions. Also, if you find any issues with the script, it's up on GitHub. I guess we can also take a look quickly over here. For example, like building the Docker image. So we're just basically running commands that you would run on the command line, like Docker image build. Pass in the name of the Docker file that we want to build, because it's not named Dockerfile by default. It's named, dockerfile.projectname.projectname, which could be a timestamp or a custom project. And then we're just tagging it with something unique, which would be what we see over here. So argument 1, argument 2, that would be formatting the project name and the project name suffix. And then there's like other little things here, like, if we read the debug environment variable, if that's true, then we just output this command to the terminal. Otherwise, we just don't output anything for debug information. And then like there's this one Python library called subprocess. It's part of the standard Python library, and you can run call on that and then pass in a command that you want to run, such as, echoing hello world or running a Docker command, whatever command that you want to run. And then we have to use shell true here because we do want some shell functionality, like converting that dot into an actual path. And then like these other commands here, like docker run, same exact type of thing. We're running Docker using Docker container run interactively so we can get some coloring. I guess technically maybe the I isn't needed and just TTY would have been enough to get color. And then for the name, just the project name and the Docker image tag, which is over here, which is really just a unique string for the project name and suffix. Same exact stuff. And then like with save, it's like, well, if save is there, then we just run this command here, which does a Docker container copy, which copies out the files from the container directly onto our file system. So you can see here, like the feature save itself is basically 2 lines, and really it could have been 1 line, but I like to keep my code formatted to not be over 80 characters. Well, technically, I guess 2 lines, but whatever. Docker remove, same exact thing. There's nothing really too crazy going on here. Delete the file if it exists, and then, only do that if we have keep file set. Supported framework, yep, we went over that before, and this is all the argparse stuff. So that's pretty much this entire script in a nutshell. I hope it helps you develop your own Python CLI tools. If you do develop your own and open source it, drop something in the comments and I'll take a look, or everyone will take a look. Cool, so that's about it for this video. Thanks for watching. I hope it was useful. If you liked the video, you know what to do. Thank you, and I will see you in the next one.